Hello! In this video, we will talk about Chapter 2, titled Chemistry Comes Alive. There will be two sections to this chapter, Basic Chemistry and Biochemistry. But before we begin, let's narrow down the basics. Matter. Matter has mass and takes up space. It has three states: solid, liquid, and gas, and is composed of elements and atoms. Elements are atoms, and two or more atoms together make a molecule. This, by the way, cannot be broken down into simpler substances. And two or more elements equal a compound. Next are atoms. There are two parts to atoms, and that is what they are composed of and its atomic structure. Atoms are composed of protons, neutrons, and electrons and have energy levels. Protons have a plus or positive charge, and neutrons are neutral and have no charge, and electrons have a minus or a negative charge. Next part is chemical bonds. Chemical bonds have three parts to them, and that's ionic bonds, covalent bonds, and hydrogen bonds. Ionic bonds are described when it's added in water, it'll fall apart. And it has anions and cations. Anions are negatively charged, and cations are positively charged. Covalent bonds are described as the strongest bonds that are made when atoms share electrons. And there are two types: nonpolar, which is equal sharing, and polar, which is unequal sharing, and they often have a charge. A rule of thumb is that like dissolves like. The next part of the bonds are hydrogen bonds. These are the weakest bonds. They're the bonds that occur between molecules, parts of molecules, and not between atoms. Water is called the universal solvent, held together with polar covalent bonds, dissolves polar and ionic. It's good to know the difference between a solvent, a solute, and a solution. A solvent is what dissolves something. A solute is what is being dissolved. A solution is a solute and a solvent together. It's what you have when you're done. An example is when you have water and tea powder. Next, we'll talk about the types of chemical reactions. You have synthesis, which are anabolic reactions. These join atoms or molecules together. An example of anabolic reactions is anabolic steroids. These build muscles. The second is decomposition or catabolic reactions. It's when you break a molecule down into smaller pieces. Three, exchange reactions. They do both at the same time. They break something apart, which is catabolic, and build something up, which is anabolic. An example of this is most of the reactions in the body are exchange reactions. The next part is energy flow in chemical reactions. You have two parts to this: exergonic reactions and endergonic reactions. Exergonic reactions give off energy. These are catabolic reactions. And an example of this is fire. It's releasing energy. Endergonic reactions need energy. These are anabolic reactions. And an example of this is if you're building something, you need energy. Now on to the second section of this chapter, biochemistry. Before we begin, we need to talk about the inorganic compounds of biochemistry. Inorganic compounds are anything else. Water and its properties. You need to know that water is inorganic. The polarity and solvent properties of water is that it is held together with polar covalent bonds. It's a good solvent, and because of its partially negative and positive charges, it can dissolve ionic bonds. Water participates in chemical reactions. Water also has a high heat capacity, and it's good at keeping the heat. Water is also a good lubricant, and it serves as a lubricant and a cushion. An example of this is synovial fluid, which is between your joints, and serous fluids. Another thing about inorganic compounds are salts. They are held together with ionic bonds and cannot have hydrogen as a cation or hydroxide as an anion, because it will dissociate into Na+, which is sodium, and Cl-, which is chloride. Salts most commonly found in the body are NaCl and CaCO3, which is calcium carbonate, and KCl. The most plentiful salt is the calcium phosphates that make bones and teeth hard. Another part about inorganic compounds are the acids and bases. Acids have hydrogen as a cation and donates a hydrogen ion. It's a proton donor, and it's between the scales of 0 to 7 on the pH scale. It has a lot of hydrogens, and when they dissolve in water, they release a lot of hydrogens and anions. An example of this is HCl, which is hydrochloric acid. Next are the base. Base donates a hydroxide ion and is on the 7 to 14 pH scale. It has lots of hydroxide ions, it's bitter in taste, and it feels slippery and are proton acceptors. Next thing to know about acids and bases are the pH. pH is a measure of how many hydrogen ions are in something. Next are neutralization, which is an equal amount of hydrogens and hydroxide ions. And buffers, a chemical that resists large changes in pH and helps with homeostasis. It should be noted that we have buffers in our bloodstream to keep pH and is heavily regulated by kidneys and lungs. The next part of this section is organic compounds. They contain carbon and are held together with covalent bonds. This section has 3 parts to it, and the first part is dehydration synthesis and hydrolysis. Dehydration synthesis removes water and joins molecules together. For example, lipids are put together by dehydration synthesis. And hydrolysis, which breaks molecules apart and releases water. They break polymers into monomers. A bunch of monomers make up a polymer. The next part is the 4 major classes of organic compounds. The first part is carbohydrates. Types of carbohydrates are monosaccharides, which only has 1 ring, for example glucose and fructose. Another type of carbohydrate is disaccharides. These are 2 monosaccharides or rings together, too large to be transported through cell membrane, so they must be digested by hydrolysis to be absorbed from digestive tract through cell membrane. An example of this is sucrose and maltose. Polysaccharides are lots of rings. They're polymers of simple sugar linked by dehydration synthesis. An example of this are potatoes, which is a type of polysaccharide, and it's the starch. Starch is made by plants, and this is how plants store glucose. Another part of polysaccharides is glycogen. It's how we store glucose, and it's a long chain of glucoses. The third part of this section are functions of carbohydrates. They provide fuel for the body, they form the backbone of DNA, and act as cell surface markers. It allows each cell to be linked to another cell and helps fight off foreign invaders. These are like ID tags, and they're polar bonds. Next, we will talk about lipids. These are nonpolar. And triglycerides are neutral fats. They're glycerol. They have two parts. Saturated fats, which don't have double bonds, they're full of as many hydrogens as they can hold. And unsaturated fats, which have a double bond. For example, vegetable fats. Next are phospholipids, which have two fatty acid chains. These make up the cell membrane. They're amphipathic, which means they have two different sides or two different ends. The heads are polar and hydrophilic, which means they like water, and the tails are nonpolar and hydrophobic, which means they don't like water. Next part of lipids are steroids. These are made from cholesterol. They need some cholesterol to make hormones, and it's mainly sex hormones. Next, we'll talk about proteins. Protein is a chain of amino acids or a polymer made up of amino acids. There are three parts to this, which is the structure of proteins, the four structural levels of organizations, and the fibrous part of proteins. The structure of proteins are amino acids. We need 20 and they are joined together by peptide bonds. And peptide bonds are the bonds that hold the chain of amino acids together. Next are the four structural levels of organization. This is the protein shape. There are three parts to this. There are actually four parts to this, which are the primary structure, secondary structure, tertiary structure, and quaternary structure. The primary structure is the order of amino acids that form polypeptide chains. The secondary structure forms spirals. Those are the alpha helix and the beta pleated sheets, which is the beta pleated sheets. Tertiary structure are the two secondary structures put together, named for one folded amino acid string. Next are the quaternary structure, which is the last part. It's made up of two or more tertiary structures combined. Next, we'll talk about fibrous proteins. First, we'll talk about enzymes. Characteristics of enzymes and the mechanism of enzyme action. Characteristics of enzymes are that enzymes catalyze reactions or speed up reactions or help reactions
to occur and serve as molecular chaperones. Mechanism enzyme is that substrate is the thing that an enzyme works on. Next, we'll talk about protein denaturation. When you denature protein, you change its shape. When you have denatured it, it will most likely not change back. You can also denature a protein with high or low pH. For example, egg whites. When you cook them, the structure of nucleic acids is a double helix, and its backbone is composed of adenosine, guanine, cytosine, and thymine. These are also called the nitrogenous bases. It should be noted that adenosine is paired with thymine and cytosine is paired with guanine. Next are RNA. RNA makes proteins. DNA stores genetic information, and ATP is the main energy molecule for our body. This is the end of the Chapter 2 outline.